So first, good evening, everyone, and thank you for inviting us to talk on this meeting. We have we see this as a great opportunity for us to present the two products that we've been designing and sending out to customers with the Raspberry company. Here on the call, we have three people from Hailo. Myself, my name is Nadav. I lead the application engineering team in Hailo Tel Aviv. We also have Gilad, who is a team lead in the application engineering team. A lot of the stuff here that we'll present, he's kind of the brain father of it. So he's also on the call and he will co-present this presentation with me. And we also have Eldad on the call. Eldad leads the product team for the Hailo accelerators. So I believe that between the three of us, we should be able to answer, I guess, all of the questions that might rise during the call. And by all means, please feel free to, as Richard said, to ask questions, to write them down. We'll be doing our best to give answers. So, just very briefly about Hailo. Hailo was founded in 2017, so roughly 9 years ago. As I said, based out of Israel, we have offices in the main places where tech company would have offices in the world, in the US, in the Far East. We have a couple of them, and also a big office in Munich, Germany. We have two lineups of products that we support and promote. One of them is the accelerator, which we'll be focusing on in this call, and another lineup of products that serves the smart camera and security camera market, which is basically a VPU, a vision processing unit. So what do we do? What set us apart from the herd, at least most of them? So we do AI processors that are specifically designed for edge inference. Many people that I meet on conventions and otherwise ask me, so okay, but I already use NVIDIA. So what do you do better than NVIDIA? So yeah, NVIDIA does great products, and to be very honest, we also use them from time to time when we need to train networks, when we need to test the ground on some architectures and stuff like that. But those are huge devices that consume a great amount of power and space and vents. And what we try to bring are devices that could run basically anywhere. And when we say edge, we have projects that are running in lawnmowers, in home environments, in entry kiosks, in many places that sits outside the sterile environment of a server room. Real time, we try to optimize our flow to be very low latency to support real-time use cases and efficiency, low power, small form factor, and also very cost effective, not only on the purchase side, but also on the operation time. No moving parts, so less things to get broken, less electricity, and overall a lower cost of ownership. In mid 2024, we've actually earlier than that, in mid 2024 it was released, but we've partnered up with Raspberry, and I think it was something that was meant to be. I mean, Raspberry, you all know, bring excellent edge devices that support a broad a broad market of use cases from home users to professional users, but they did lack a little bit on the AI front. And we brought an AI processor that was specifically designed for edge use cases. And together we've designed the first AI hat that is based on the Hailo 8 chip. It has two variants, one that consists of 13 tops. This is the Hailo 8L, and one that consists of 26 tops. It can be used with passively cooled in a closed enclosure. This is still a very successful device. I think at certain times it was the best-selling add-on for the Raspberries. It brings best-in-class vision performance, supporting the capability to support multiple video streams, or to apply analytics on multiple video streams in high resolution and in real time. For that sake, and when we say real time, we mean 30 FPS or more. And we see it already deployed also on the home front for home security. Namely, we see a lot of integrations with the FreeGate package, the FreeGate OpenMVR. We see it used for safety, for analytics, and we already have a number of, let's call it professional or commercial use cases that use this platform at the heart of the product. Early this year, we've introduced the Pi AI Hat Plus 2. This one is based on the Hailo 10, which is our next generation AI accelerator. This one brings 40 tops in 4 format, also passively cooled. It comes with 8 GB dedicated LPDDR, and this is the game changer here, or at least gives us a whole new range of possibilities and workloads that we can use this AI hat for. And in addition to all the use cases, pipelines, or flows that you've been able to run on the original AI hat, this one also supports ASR. ASR stands for automatic speech recognition. I'm sorry, it supports small LLMs and also small VLMs. We'll get later in this presentation, we'll get a little bit more into the details of LLMs and VLMs. So if those terms, I'm sure LLMs you know, but we'll get a little bit more into the terms and the technicalities that form those architectures. I want to emphasize the LPDDR presence here on the hat next to the Hailo chip. And this means that basically we can run significant AI workloads that consist, as I said, small LLMs and VLMs, and also all the vision stuff, with basically almost no impact on the base system. I mean, almost no impact on the CPU or on the memory of the Pi itself, which means that the Pi itself can run whatever else you want to run on it. GUI stuff, classic computation, all the networking of the device, etc. It gives a very, very good flexibility in terms of how you, of what you can run on the device if your application is AI centric. So what are the use cases that we see? So first, as I said, analyzing multiple video streams at real time. As I said, real time, 30 FPS at much larger resolutions that you might have been able to do if you haven't had the hat. or if you've been using one of the older generation accelerators that were out there in the market. And we see this already being deployed in drones, in different agriculture products, in home servers, and a lot of people using it as a very convenient platform for prototyping. You start on a Pi with all the support, with all the software packages that are already out there, with all the community and all the questions and answers that are already out there in the web. Yes, and then sometimes you go deeper in terms of embedded device, or you create a cluster of Pis if you need more compute power. It allows you to work with very low latency on the vision pipeline and all the privacy of the on the edge analytics, especially for people who are more concerned about the machine that is being able to recognize their figure, their faces, etc. So here everything runs directly on the edge. Nothing leaks out, and there are no traces unless you want them outside of the device. Another thing that the original hat enables us to do is what we call zero-shot architectures. Zero-shot are very interesting. If you think about most of the computer vision part of AI, it's only good for what it was trained on. A very common example that if I have a network that was designed to recognize different breeds of dogs, so I present a dog and it will tell me if it's a Rottweiler or a Golden Retriever or a Chihuahua, etc. Even if I place a cat image in front of it, it would recognize it as one of the dogs, because dogs are its whole universe. It doesn't know anything outside of the dogs. Zero-shot introduces a new concept that networks that are trained in a much more generic way, you are able to ask them, or they are able to detect objects or classes that they were not trained on. So I can ask the network if the picture is of a person with a hat. Okay, no one trained the network to recognize a person with a hat, but zero-shot allows me to do those type of analytics. And we think it's really cool because the burden of training or retraining networks. Yes, I mean for some it's easy. For some it's under fingertips and they can easily retrain a network. But for a big part of the practitioners, of the people who want to use and deploy AI, you don't want to mess with the retraining. I mean, you rather take something off the shelf and change the classes. Maybe I want to, in most of the data sets, there's the class of a person. It doesn't know if it's a man or a woman. Maybe in some situations, for me, it's important to understand if it's a man or a woman. With zero-shot, I can do that. So those type of applications are very interesting for us. And all of those are applications or pipelines that you can run on the original AI Hat that is empowered by the Hailo 8. With the new hat, we've also included event triggering with on-the-fly user-defined event. So this takes the concept of zero-shot, but really enhances that and gives the ability to detect scenarios or real-life scenarios that are not restricted to a single image. So you would be able to detect if a person had fallen. You would be able to detect basically events that you define with text. So this is very, very exciting, and this capability is based on the VLM type of networks. Gilad will explain a little bit more on VLMs very shortly. Voice to action pipeline, I think this is also a very exciting area. So we see many people that want to simplify or enhance what is otherwise known as HMI, human machine interface. So instead of typing something on a keyboard or putting the input in this type of manner, you would say something. There would be an LLM, that there would be first an ASR network that would take my voice, transcribe it into English or any other language, then take this into a dedicated LLM that could understand the meaning of what I'm saying, and then the output from the VLM, from the LLM will be a command for another tool. Could be something on the Linux subsystem, could be something physical to activate lights or any controller that we want to use. And yeah, I mean, you might say, yeah, of course. I mean, we've seen this before. I mean, you say a command and then it happens. Um, the the strength of this is lies in the LLM capability, because we know, as you know, with LLM, there is a big room for leniency. I do not need to spell out the exact command. For example, I'm not sure. I don't know if you would. I'm sure you understand this example. If I have voice control in my car, but if I want to close the windows, I need to be very specific. Close the window, and I mean, also, being Israeli, my accent is not perfect. I need to say it at least twice or three times, and until the voice recognition in my car detects my command and actually does it. Basically, I don't use it because of that. With LLM, I can be much more casual about it. I can say, close the window, please close the window. Can you please lift the window? Can you please, I mean, I'm chilly. I mean, you could be much more lenient about what you're saying, and still the LLM would figure out and issue the right command to the next tool or part in the pipeline. So a little bit of benchmarks. So first, talking about the classic AI, this is the computer vision part of the AI. So you would see here the three devices or the three heads that we currently have. The first one is the Hailo 8L. Then the Hailo 8L is the one with 13 tops. Hailo 8, the one with 26 tops, and the Hailo 10.8, the one with 40 tops, and the additional DDR. And I think the numbers basically talks right through. I mean, you can see, for example, VIT. VIT is on its own is not it's not very maybe interesting. VIT stands for a vision transformer, but it's a very basic architecture for all of the modern computer vision. Almost all of the computer vision architectures first do a VIT and then do something. They do a VIT and then do whatever segmentation. They do a VIT and then they do a detection, etc. So it's a very important block, and you can see here how the performance goes up on this architecture. And it also goes to object detectors, classical ones like the YOLO V8 or the YOLO 11, and pose estimation. So really the close DDR that sits next to the compute chip, this really makes a difference. Not only that it reduces the footprint, as I said, on the Pi system, it also enhances the overall performance of the AI pipeline. Gilad, you want to take it from here?
Yes. Hi, guys. I'm very excited to join you. So let's start talk about LLMs and generative AI. So first I want to level the court and speak a little bit what is LLM and how it works. So we'll be able to talk a little bit more about it. So LLM is playing the guess the next word game. This is what it does. Uh, we just took a model and give it literally all the text knowledge that we have on the internet. The big AI companies scraped Wikipedia and everything that we actually got on the internet and use it to train a model. What allows us to do it is that we are using a self-supervised learning. If until now we have to have a human in the loop in order to prepare the data set, we have a human to say, this is an image of a cat, this is an image of a dog, and use this data set to train models. When we are using the text, we can use a self-supervised learning, meaning we do not need a human in the loop. There is no way a single human or 1,000 humans would be able to annotate all the human data that we have on the internet. And the way that LLMs do it is by taking a body of text and they're just hiding on deleting some words. And then the model task is to guess the word and complete the missing word. So if, for example, we take a sentence, we start with the sky is, the model's job is to guess the next word. And this is how LLMs work. Because we don't just ask them to guess simple sentences like the sky is blue, and we also ask them to complete sentences like in quantum mechanics, this phenomenon means that, or we are asking doctorate level questions. We force the model to understand and to have deep understanding, first of all, of the human language, what words mean, grammar, and also to distill real human knowledge. If we ask the model to say, to complete the sentence, the king of Ethiopia in 1834 was, and he needs to bring a name, this data somehow have to be encapsulated in the model. And because we are able to pour basically all available human knowledge into the model and ask him to complete a random word in this knowledge, we actually force him to learn all human knowledge and understand language and the way words are relate to each other, and it really learns a lot about the human knowledge. So this is the game, and when we are using ChatGPT, what it actually does is guess the next word. So Nadav, let's skip to the next slide. So this is how it looks like. This is what we call the token by token loop. So if we want to ask a question in the model, first of all, we have the system prompt saying you are a helpful agent or whatever. And then we says, okay, the recipe for a Raspberry Pi is, or just give me the recipe for Raspberry Pi. But because he had the system prompt, he knows that now the next thing the next word should be the recipe for a Raspberry Pi. So we take this sentence, we tokenize it, we decode it into tokens which can be interpreted by the machine. We take all the parameters, all the learned knowledge of the LLM, we combine them together with a huge amount of compute, and we output one single word, actually not even a word, a token, which might be half a word or something like this. So in order to generate the next word in the sentence, we need to do this entire inference, which includes a huge amount of compute and a huge amount of data, a huge amount of memory. And then we want to generate the next word, and we have to do everything again. We take the new generated word, concatenate it to the past sentence we have, push it again to the model, and again, generate the next word. And on every iteration, we have to do a huge amount of computation, and which involve a huge amount of data that we should get from memory. Now, two things can be the actual bottleneck of this algorithm. We do have a huge amount of compute, but actually in LLMs, the bottleneck is the memory. Because if we have 3 billion parameters, and we need to fetch 6 gigabytes of memory each time we generate half a word or even a word, the bottleneck of the memory becomes the issue. And now we can face the elephant in the room. how come an AI chip built specifically for AI generate the same token by token generation as the Raspberry Pi CPU? This is because the model is not bounded by compute, it is bounded by the memory. And because Hailo and the Raspberry Pi CPU has the same DRAM with the same interface, we both are limited on the amount of tokens that we can generate by the memory bandwidth of the DRAM. Now, what can be done? As we said before, on the initial stage, when we give the system prompt, we actually know all the words in the prompt. We do not have to ingest one word at a time. When we are generating the next word, we can't guess the third word before we decided on the second word. But if we need to read an entire book or read an entire system prompt, we can do everything together, and the memory bottleneck is really lowered, and we are able to ingest multiple words in one pass of the inference. This is called the pre-fill stage. And in the pre-fill stage, we can really see the advantage and the higher computability of Hailo. And we will see that in this stage, when we are not memory bound, we can really execute our compute and give much better performance than you can do on the Raspberry Pi CPU. Let's continue. Excellent. Okay, so here you can see a comparison between the amount of weights and the amount of compute required per model. The three left columns are ResNet and Inception, just video analytics. You can see that it requires a lot of compute, and also a lot of memory, but it's pretty much balanced. When you are moving to the rightmost column, which is Llama 7 billion, you see that the amount of compute is much bigger than the older models. However, the memory required is in several orders of magnitude bigger. And this is really emphasizes the memory bottleneck of LLMs. Okay, let's continue. So now that we understand that, we can compare how Hailo runs LLMs in comparison to the Raspberry Pi CPU. So everybody saw Jeff's video, and you saw the performance around, let's say, 8 tokens per second. This is the output column. If we are looking at the 1.5 billion Qwen2 instruct network, but note the prefill column, which is the part that we do ingest a large amount of defined data, system prompts, or an email we want to parse. And in this stage, we can run a 300 token per second, not an 8 token per second, because we are less memory bound. The Raspberry Pi CPU cannot match this. So if, for example, you have a task which requires reading lots of data from sensors, or reading emails or something like this, the time to first token running on the Raspberry Pi will be much longer, because also the Raspberry Pi gets some speed up on the prefill stage, but it's an order of magnitude less than what Raspberry Pi what the Hailo can do. So if you need to read a huge email and then just answer something about it, if you are running on Hailo, you will get the response much faster, because the prefill stage can be heavily accelerated. Okay. By the way, there are also the Whisper benchmarks, which are also enabled on the Hailo 10. We have a Whisper base and Whisper small, and both of them can run in real time, so we can add text to speech to text on the Hailo 10 as well. Okay. Sorry. Okay, so some best practices when you are using LLMs on edge devices, especially on the Hailo. So first of all, the main bottleneck is the token by token generation, the output generation. So you should try to use the shortest outputs you can. Excuse me for a second. Probably need a beer. Okay, so if, for example, you want the LLM to decide whether you need the light switch on or off, don't let him thank you for asking him and glorify this was a great question. Just tell him, please answer yes or no. If you are doing this, you are minimizing the token by token generation time. You can give it as much as a big input as you want because this is heavily accelerated at the pre-fill time, but you want to minimize the token by token generation, which is memory bound. So if, for example, I want to get a specific task done, if you want to generate text, of course, you need to keep generating a token by token. But if, for example, I want to get some action done or get some decision by the model, it is better to add 50 words in the system prompt to make sure that the model will output the specific output you want in a JSON format or in a single word or even a Boolean output. And this will probably run better with better latency than if you let the TBT stage run and give some kind of random answer. Okay, so let's switch to VLMs. VLMs is visual language model. Sadly, this is one of the best models we can actually accelerate it on the Hailo 10, and it was not advertised enough in the Hat 2 release because Raspberry Pi do not have a demo for it, but we definitely have it in our Hailo apps that we will give you the GitHub address later on. So a VLM is a visual language model. Basically, it's an LLM. You already use VLMs. Whenever you upload an image to ChatGPT or Gemini, you are actually using a VLM. So an LLM get a text input, embed it into tokens, which can be run by the LLM. A VLM is also able to get an image, run it through an image encoder, which converts it to the same embedding space of tokens, which can be used by the LLM. This image encoder is also a highly compute model, which can be hundreds of megabytes, but this can be heavily accelerated on Hailo. This can be parallelized. We can run multiple images in a batch, and you are not bounded by the memory because you get the entire image, you crunch it down, and you just output tokens that will be sent to the LLM. Another advantage we have in VLMs is because you need to generate these image tokens and add it to the LLM context. This is not a small amount of data that you need to add. And because this is a pre-fill stage, we can do it much faster on Hailo than on the CPU, which do not have this kind of acceleration. So you can see here a benchmark. The first column is just for the image encoder. This is VT-Huge. It is used in multiple VLMs. This is, I think, 600 mega parameters. And you can see we can run it at around 300 milliseconds. On the right column, you can see the entire flow of Qwen2 VL, 2 billion parameters. So the time for first token is less than a second. It includes getting two images, embedding them, and ingesting them by the model, and outputting the first token from the model, which, if you are planning your application right, should be yes or no, or a very short output. And thank you. Okay. So in this, press another one. In this slide, I just want to align expectations to which kind of models can run on the edge, not only on Hailo, on the edge. When we get used to things very quickly. 3 years ago, we were excited as hell when we would be able to say to the computer, generate a sofa that looked like avocado, and we will, wow, this is amazing. And now if we ask the AI to generate an image, but it gives us a sixth finger or something getting outside of the connecting heads or something like this, we are saying, oh, this is crap. I don't want to work with this model. The same thing happened with AI, and we get used to what we currently call AI very, very quickly. What we forget, I believe that you guys know it, but most of the people, they got it in their phone. They say, yeah, no problem. I can ask my phone right now who is the president of the United States, and we will also tell me, yeah, this is a great question. You're a genius. I'm very happy to answer. What we forget is that in the background, we are actually talking to a huge supercomputer, which is $100 million technology. And there is no way you can run a model of this size on an edge device or even a consumer or a prosumer product. So let's just compare the numbers between. Give me just one more second with this slide. Let's compare the numbers for Chat GPT 4.0. It uses 1.8 trillion parameters and above 1 terabyte of memory. This is 1,000 times more compute and memory than we can run on our edge device, not only on a Raspberry Pi. I mean, on your laptop at home or on your gaming PC. For reference, if you want to run 70 billion parameters, you will probably need two good GPUs, just to have enough VRAM to run it. So we are talking about 1,000 times less compute for the models that we can run on the edge, and we must understand it, because the first thing that people said when we released it, okay, how do I compile the 4.0 on the Hailo 10? Okay, now we can continue. Okay, so after I bumped you up, let's see what it can do. So Nadav already said before, we should not see the small model, 2 billion parameter, 3 billion parameter, as a dumbed down version of ChatGPT. This is a very, very capable model. Just to emphasize, also a 2 billion model probably have better English than I do. It understands word, it understands grammar. You can talk to it with free language. And as Nadav already said, it is an excellent human-machine interface combined with text-to-speech and speech-to-text. You are free from all the regular expression template you have to talk with Siri, and you can just speak freely. Also, kids can do it, and you don't have to teach yourself what is the exact template Siri or Alexa want from me in order to set up a timer. So this is a huge advantage that you can currently run on the device without connectivity, fully private. Okay, let's continue. Let's talk a little bit about the VLM. Nadav already emphasized the zero-shot classification, and because we also have, it is basically an LLM running in the background, which has the ability to understand images. So its ability to generalize is much more than what we can do with classic video analytics. If video analytics can tell you a person, you can ask the VLM, don't alert me when there is a person passing by my porch. Let me know if it's the pizza guy. Or you can ask him, is the cat is in the box, near the box, or below the table? You can do this kind of stuff also with classic computing, but you will have to handcraft the algorithm. When you have a VLM, it's much easier to generalize and to actually code new application without really the need to code. You just need to prompt the model right. Another awesome use case is analog to digital conversion. Let's say, for example, you have a pressure gauge for your gas at home, and it's probably there for a long time, and you want to connect it to your home assistant. You will probably be able to do something to digitize it, but I bet it will void the warranty and will piss off the guys at the gas station. But now the solution is very simple. Take an ESP, a $5 ESP camera, point it at the gouge, and use a VLM to read the gauge. It allows you to not to just do the text stuff. It allows you to ask questions. It's not only you, it's also the model. You can prepare some kind of decision tree in advance, and the model can ask itself questions about what it sees and act upon it. This is a huge advantage, and all of this can be done using prompts. No need to do any coding. Let's continue. Okay, the last thing I want to talk about, and I think this is the really the biggest game changer. LLMs and VLMs allows you to run tools. If you are running AI on the edge, you don't want to get a text in, text out. You want to get real actions in the real world. And with LLMs and VLMs, the model itself, and you are able to get information from the real environment using real data in real time and act upon it using real actuators, real, I don't know, LEDs, motors, arms. And I think this is really the biggest advancement when you want to bring AI to the edge. You want to do it in real time and really in the real physical world. And tools enables you to do it. And I'm really waiting forward for the Q&A to hear what you guys think can be done with these tools. Okay, thanks. You're on mute, Nadav.
Thank you, Gilad. So very briefly, getting down to earth, so how can you use all of this goodness? So, I mean, if you have the AI hat plus the Pi, all you need to do is either the apt install Hailo All for the original hat or the Hailo H10 All for the newer hat. And this gives you all the runtime packages that you need. We also highly recommend to at least take a look in our Hailo apps and a GitHub repo that has a broad support for different AI models, different AI pipelines, going from classic stuff like depth estimation, object detection, pose estimation, and also Gen AI, like the VLM that Gilad described, and LLMs. And we really see how very recently the trend for this GitHub is going very high. So yeah, we invest a lot of time also on supporting people that have issues either on our community forum or on the GitHub itself. More resources, mainly for hardware developers, people that need the data sheets and stuff like this, can be found on our developer zone.
Yeah, I want to add that we added a lot of effort to do all the heavy lifting by ourselves. We got ready-made pipelines for detection, segmentation, whatever you want. You just get a Python callback, which will get called for each frame with all the data already inferred. You don't need to control the camera. Everything you need is handled by us. Just get the AI outputs and do your thing. So it's very, very easy.
Yeah. Very recently, we've added in our developer zone an ability to ask questions, our AI engine. So different stuff, either on the runtime or on the build time, you can ask and it will give you very good answers. For those of you who like to chat more than to search in documents, we now have this capability embedded in the developer zone. We also have a very vibrant community forum that we monitor. So you might be answered by someone from the community, but you're also very likely to be answered from someone from my team or either myself. We are very keen on it. We try very hard to get all the topic answered. So I'm very inviting every one of you to try this out. One last thing that I want to mention, and then we will go to the Q&A. One very awesome factor that very recently materialized is, I mean, at Hailo, from the very early stages, we tried to put as much as we can as open source software. And even today, I think something like 90% of our software is open sourced. And with modern Gen AI tools, Claude, Copilot, etc., we can do amazing stuff. And this is something that I've just tried a couple of days ago for this presentation, but I think it's really awesome. So I took a bunch of resources into NotebookLM. So our GitHub of the examples and Fast API and React, and basically I started to chat with the NotebookLM, asking the notebook to describe how would a fitness application would look like if it need to be based on the pose estimation pipeline coming from the Hailo apps. And I've asked it for three capabilities: to count pull-ups of a single person, to measure how much time a person is in the plank position, and to be able to count push-ups. And after I've chatted a little bit with the notebook, I just copied this. I asked it to concentrate it, and then I copied it into my Copilot, and basically that's it. I got a full app. It's not perfect. Okay, of course, there are some quirks here. I mean, the pose estimation here goes a little bit off. Okay, but it did work, and I would, to be super honest with you, the thing that took me most of the time was to find a good video of someone doing pull-ups to check the app. So I mean, we are living in an exciting times. But I think obviously this is running on a Raspberry Pi plus Halo, and I think using the Pi, using the hats and the ecosystem that we are slowly growing. You can see here a number of partners that we already have in the ecosystem, and we are working on adding more important partners into this ecosystem to be fully compliant with the Halo devices. Yeah, I really think it gives the best in class AI experience and AI performance that you would find for edge devices. So maybe with this, I will open the mic for any questions or comments or anything that you might want to bring up.
Great, thanks for that. I guess I did have a question. So I do have one of your hats. They gave me one. Raspberry Pi sent me one to try it out. I did have a little bit of a play with it, but I didn't really get enough time to do much with it. So I just wonder how I would start this application. So I've got two cats, and they're both too fat. So I want to create a little system that detects which cat it is and only opens up their bowl. So if they stand in front of the wrong bowl, they don't get fed. So how would I go about doing that with your hat?
So, Gilad, you want to take it?
Yes, I think you should use a two-stage approach. First of all, just use YOLO to detect the cats. Once you have the cat you want to detect which cat is which. You are able to train a small classifier network in order to do it, but you can take the shortcut, and this works also on the Hailo 8. You can just use the clip network. This is a zero-shot network. So take the cat, run it through the clip, and you get some kind of embedding vector. Do it for both cats, and clip, what it does, it allows you to extract details from the image. So for example, if one cat is black and one cat is redhead, this embedding should encapsulate this characterization. So you can just take both have a vector. It's very similar to face recognition, but instead of using the face recognition, you use the clip embeddings of the cat. Grab a few samples, and then when you have a new sample, run it through the clip and see to which group it is most similar. So you don't need to retrain anything. And if you have a new cat, just edit its embedding. And you can actually use our face recognition app, which do the same only with a face recognition network. Just switch it with clip, and you are able to actually recognize anything.
So with an experienced user, how long would all that take? Just like half a day or something like that, or a few hours, or?
If you are using an AI and you are guiding into the correct network, I think the AI will tell you, yeah, we'll have first week integration, second week, but eventually it will finish it in a few minutes.
Yeah. Cool. So what sort of applications have you guys seen already? Like, there must be lots of people doing lots of things in the community, and just wondering what sorts of things have you seen?
Yeah, so yeah, we've seen very cool stuff. We've seen people taking advantage of the low power and hooking it up with solar panel energy and putting cameras in parks or forests to identify poachers. We've seen people putting it in also on the wildlife front, detecting different breeds of birds in the birds feeding stations. Obviously, home safety, Frigate has been a huge success. A lot of people like to hook up a number of cameras and be able to detect stuff. On the more let's call it professional front, we are seeing a number of medical use application. So there is a high tendency today to try and treat people in their own homes. So not keeping them inside the hospital, just if the situation allows it, to send them to home. But still, I mean, this person needs some care. So a camera with full privacy. I mean, your images would not leave it. Everything runs on the camera. This is a huge advantage. And if, for example, if you sit, especially for older people, they tend to sit a lot of time and not walk and do some exercise. So if you sit for a long time, it will send an alert to the system. If you fall, that's a huge risk. It will also send an alert. So we are seeing stuff around this area. And some other fun projects that I mean, like the cat problem. So fun projects like I want to do an alarm every time the dog goes on the couch and stuff like this, which is always fun.
Cool. Is it possible, like, to daisy chain them? So if you have a few hats, how would you make them work together to accomplish a goal, or can you do that? I guess they each need their own pie, do they? And how do you?
Yeah,
to transfer data between them or anything like that?
Yeah, the hats connect through the PCI interface to the base to the SBC. So you only connect one. So if you want to do multiple, you would have to connect them through the PI itself, not head to head,
Okay.
like over networking or any other solution that would make sense.
And I know you create, like, you don't just have Raspberry Pi hats, you also have like standalone like USB
Right.
devices and stuff like that as well. Like, what's the main difference between them? Is it just you get better performance out of the Pi because it's PCI, or is there any major differences?
Yeah, so we do everything from selling silicon for bigger projects that want to design their own PCBs, through M.2s that are easier for integration, but still require some sort of empty or vacant slot, through stuff like the Pi. And we also have bigger cards that's supposed to serve, let's call it local server, or example, if you have a car dealership and you have, so the Pi can support maybe 4 cameras or maybe 6, depends on the amount of analytics and the FPS that you want to achieve. But if you have 40 cameras, so maybe the Pi is a little bit too big for that. So a car dealership that have, let's say, above 10 camera would use something like a local server station. So the advantage is basically uh, directly attached to the use case. If you already have a kind of a NUC and you want to use it, so M.2 is the best solution. If you want to use it on Windows, you don't like Linux, or you're not used to Linux, then that's also something that would differentiate. If you need more analytics power, like more streams, or doing heavier analytics per stream. A few years ago, Gilad created a nice demo that was nicely called tons of stream, basically digesting 50 streams in a single station. Then you would need something that a little bit stronger. So it really goes down to the system that you want to have.
Right. So when I was playing around with your hat, one thing I found a bit interesting was when I asked a question, I just said, "Tell me everything you know about Raspberry Pi," and I went away and came back with an answer that wasn't that good, frankly. It was okay, but I wasn't really expecting perfection. When I asked it a second time, a similar question, the answer got better. And every time I asked it, it seemed to get a better answer. But maybe it's just the way I was asking the question or something like that, or is it actually learning in real time as well? Just wonder how that was working.
No, so the LLM does not learn in real time. The only thing that changes in real time is your context. So if you are staying in the same environment or in the same context,
Okay.
it's keep adding up and it kind of accumulates this knowledge. But no, but this is actually very something that we would expect. And Gilad mentioned it. I mean, there are use cases for the LLMs, which, frankly speaking, are just, above its head. I mean, if you want to use it as a code completion, I mean, technically it would work, but realistically, using a 1 billion, 2 billion, 3 billion model for code completion would give you poor results. I mean, it's not nearly as good as the online models. But if you want to use it for very recently, again, Gilad created a very nice demo setup for a presumable elevator controller. So in elevator, you are able either to press the number of the floor that you want to go, and the equivalent of that in voice would be take me to floor number 2, please. So you would be able to do this. You would be able to ask the elevator to take you by the floor content. So if we are in a hospital, for example, you would tell the elevator, please take me to the surgery room, or please take me to the pharmacy floor. I mean, I know where I want to go. I don't remember what floor it is. And then this exactly where small LLMs plus the prefill comes into play. So imagine that the prefill is the whole hospital index. So the LLM knows where the pharmacy, where is all the other departments. So I don't need to remember. I can just say. I can also say, take me 1 floor below. I mean, this is exactly the power of LLMs, and prefill. But if I will ask the 1 billion LLM, I don't know what is the best method to make pasta. I know I might get an answer, but a decent answer, but it's not let's call it a designated use case.
Right. Great, thank you. Any other questions there? So I don't know if there's some in the
Yeah, we have questions in the chat. I see.
Oh.
Salman asked about do we have some community project with OpenClaw? And yes, we just yesterday, actually, one of Hailo employees did the integration with the Olama and the OpenClaw. I must say that I just posted it in the chat. You can search our community to see what people are doing and also see our GitHub to check out for more projects. The fit to OpenClaw is not that good, I must say, because OpenClaws use tools and it requires a very large language model in order to fill in the gaps and to just allow people to just talk to it. So you are able to connect, and as you can see, people have done it, but I would hold my expectation regarding what this model can do, because the OpenClaw and all these very big infrastructures assume that they are speaking to a very large model that can take a very large amount of information and complete the gaps and solve for itself what the infrastructure will not support. So you can connect it, but I'm not expecting it to work as you expect. But definitely for simple tasks you are running at home, for example, read my email, summarize the email, search my file system, run this script. This is definitely something that can be done. So there are definitely use cases that the small model running on the Pi can't give you good support in OpenClaw, but it is not the general case. However, adding VLMs and stuff like this into OpenClaw will really allow you to lower the bar of interfacing, for example, with your computer, with your cameras. You can just use OpenClaw. Okay, write a script to get data from the camera and then use Hailo infrastructure. I mean, you not have to use the actual LLMs in order to do it. You can do it, but bear in mind that when you have Hailo, you also have detection, segmentation, all the video analytics, and the text-to-speech, etc. So you can definitely utilize Hailo in the OpenClaw environment to speed up things. And also you can try to save bandwidth, try to do it with Hailo. And if not, go to the cloud.
Any other questions from anyone? Anyone else in the room there? Pub? No. Cool. Thanks very much. That was very interesting. It's a very interesting and confusing and difficult area at the moment. There's lots of things going on. It's hard to know what bits to chase after, really. So really appreciate the overview. It's really useful. Thank you very much.
Thank you very much.
Thank you very much. It was fun, and yeah, we pretty much like to host every one of you in our community forum. So if you have any follow-up questions later on when you try, you experiment, don't hesitate, post it there, and for sure it will create an interesting discussion. So thank you very much, and have a nice evening.
Great. Thanks so much.
Thank you.